in this table, they have summarized whatever that we discussed in those paragraph into a single table right now. So here you have to look only this line. Right, 14.3K bytes, 8192. So here we saw no memory. When we talk about memory, 8K into 14 words, right? So 14 words, we get 14, but each word is, what is the size of each word? Fourteen into 8,000. That is what they are saying, but it is very 14.3K only it is coming now, but here it is more, right? Come on. Byte wise 14.3. Instruction wise 8192. If that is the case, what is the size of one instruction? Can I divide this 14.3 divided by 8K now? So let us do like this: 14,300 divided by, oh, sorry, 14. Eight, 1, 9, 2. 1 byte, 1.7 byte. No. So each instruction 2 words then. Total number of byte is 14.3. That's what approximately one instruction require that 14 bits will come, I believe. 8 bit is 1 byte right now. So remaining half byte is 6 bits required. No, 14 bits means we require 6 bits. 6 bit is nearly 70% of 1 bit. That's why we are getting 1.74 byte. 1 byte completely, additionally 70% of another byte. Maybe that's what one instruction will have 14 bits. That is what my understanding. One instruction will have 14 bits. Actually, here they made mistake. It is not word. They have to say 14-bit words right now. If they said 8K of 14-bit words, they said 14 words. That is the wrong, that lead to wrong interpretation. One instruction is having 14 bits in size, right? So like that, you can have 8K instructions. If you have like that, the total number of byte you require in the memory is 14.3K. Do you are you clear about it? What I mean? Because I think this is what they are saying here is 14-bit word. That bit is missing here. One instruction will require 14 bits in the flash memory. Like that, you can have 8K instruction. 8K 14-bit word. 14-bit word, because one instruction itself it require 14 bits, no, which is more than 1 byte. That's why we get this 14.3K bytes. Is that clear to you or you have doubt? Come on.
Yes, sir.
What you understood? Explain me.
So we have this 8K 14, 8K 16, this one word, sir.
8K words mean one word. What is the size of one word? See, one instruction, no. One instruction, let me explain in this way so that you will get a clarity. Because I speak in with my understanding. So let me explain that. Let's say I have different instruction, right? Instruction as move A, comma B, something like that. This is one instruction, single word instruction right now. This instruction require 14 bits. 14 bits means, let's say it is having 1001. This is 4, 8, 12, some more 14. Agree? Come on. This one instruction has this much byte, this much bit. But as per computer, in a computer, the unit is in terms of byte. So 1 byte is how much? 8 bit. This is 8 bit. Agree? Come on. This is 1 byte.
Correct, sir.
Right. But when it comes to this MSB part, it is not completely 1 byte. It is only 6 bits. So the 2 bits are empty. So we are using to represent a one instruction, we use one byte completely and 75% of another byte. But these remaining 2 bits, no, they want to simply ignore. They won't leave that without programming. They will bring in another. For example, in the next instruction, I have something like branch to, actually this is 2 instruction cycle. Let me do like add working register. I have this instruction. This instruction is also having similar way 14 bits. Right now, let us say this is instruction set for add working register. What they will do, they will go and flash these 2 bits in this memory location. Actually, they will do it from the LSB. So they will put this 10 here and then this in another byte. Like that, when we total number of instruction that we can store in a microcontroller is this much of instruction. 8192 instruction, 8192 14-bit instruction you can store in the flash memory. When you do like that, total memory required with respect to flash memory, which is 14.3 K. Because one instruction consumes 1.7 bytes in the flash memory.
Okay.
Do you understand now, both of
Yes,
you?
sir.
Amir?
Yes, Ansari.
Clear now? So
Yes,
that is why that is what they are trying to say. So you can actually, this is a mistake, maybe the typo error. This mislead us actually. So we have to say 14-bit words. 8K of 14 bits words. When you do like that, we will get to 14.3K total flash memory we require. And then these are internal RAM. internally in microcontroller, we have this much of RAM memory, SRAM, right? Moment you turn off the power, this memory will become blank. And then 256 bytes of EEPROM we have. IO pins, totally 33 pins can be used as IO pins. Actually, totally 40 pins. 7 pins may be used for power, reset, ground, for those. We cannot use them for IO. So among the 40, we can use 33 for IO. And then you can do digitize input from 8 different channels. And compare logic PWM wise, you can do 2 PWM generation you can do. And then SPI is supported, I2C is supported, USART is supported. 8-bit timers are 2, 16-bit timer is 1. Totally 3 timers. Comparator wise, they have 2 comparators. This is a rule of thumb for our microcontroller. Even you can memorize this. So 14.3K flash, 8192 14 bits words that we can store. RAM is 368, EEPROM is 256, total IOs supported are 33. We can digitize input from 8 different channels. CCP and PWMs are 2. SPI, I2C, USART all are supported. There are 2 16-bit timer, 2 8-bit timer, 1 16-bit timer, and then 2 comparators. Right? That is the thing. With this, we can end our today's walkthrough. Let us explore the data sheet further tomorrow, because data sheet is a thing that we have to discuss and have to brainstorm before we do programming. If we have a gap in this, we will have a gray area while we are doing programming, so that we won't understand what we are doing actually. Right?
Yes, sir.
Right now. Okay, team. Thank you.